Hi, my name is Corey Johnson, and today I'm going to be showing you my latest work on my game project, currently called Crusade. The project is still at a pretty early stage of development. I only began work on it in mid-August 2009, about 3 months ago, and there's still a decent bit that's already been implemented, so we'll go ahead and fire up the program. First things first, I'll be showing you the server, which runs separately from the client. One of the first things to note here is that the game uses a couple of different libraries to help out. Here we have Havok, which we use for physics and animation. We also use Boost Python to integrate a scripting system. And finally, I've written my own custom multi-threaded architecture to facilitate both good multi-core performance as well as easy-to-use, bug-free communication between all the different systems that we have. Alright, so let's fire up the client here and demo some of these features. As an aside, I use Erlicht, an open-source scene graph, to assist with rendering. Alright, so the first thing first, we'll show Python scripting that I mentioned earlier. Here we have an image of our login, which we can see is notably off-center. Luckily, since our UI is done through Python, it's easy to fix this issue, and it doesn't require any recompiling. We'll just open up the Python script that's responsible for the login UI, and then fix the values, which I've purposely set to the center left. And once I fix those values to be entirely center, I'll save the file, and we'll actually see that in some cases that's all that we need to do. The code can actually detect that a script has changed and reload it automatically. However, since we're dealing with the UI system, in this case we'll actually need to restart the program to see those changes show up on screen. So I'll go ahead and do that now, restart the client, and voila! The problem is solved, the UI is centered, and there was no recompile of the game required, just saving the script. Alright, so now that we've fixed the UI, let's actually log into the game. One thing to note is that the scripting can communicate over the networking to the server using TCP networking, and there's no real voodoo magic involved to that as far as coding goes. We basically just use Python's own ability to pickle information and send it across a stream, and we send that straight across our TCP stream, although networking is on a separate thread, and that's all that needs to happen. Alright, so here we see our character, complete in all of his cel-shaded glory. As I mentioned earlier, we use Erlicht, an open source scene graph, to help organize rendering. But the outline and the cartoon shading effect that you see were done myself with the help of a couple of far more knowledgeable graphics folks than myself online. Basically, we use vertex and pixel shaders to step the diffuse lighting component along a gradient to give the character the cartoon-like effect. And then we use a depth map to compute significant edges on the screen to outline. And once this is done, we draw everything out to the screen. As I mentioned also earlier, we're using Havok for physics and animation, so my character running around here on screen is having his movement data sent to the server, verified, and then broadcast back out to all the clients. Both the client and the server are running the same version, if you will, of the Havok physics simulation, so there's no discrepancies when they simulate actions. All of this is done using what's called client-side prediction and entity interpolation. Basically, this is a lot like what you see in most modern FPS games. Sometimes it's also referred to as rewind replay logic. Basically what happens is when I move at a certain point in time, I broadcast my movement along with the time I think I moved at relative to the world, and I send it all to the server. Due to latency, the server sees that movement sometime in the future. It then rewinds to when I said I moved, applies my movement, and replays all the things that have occurred since then until it reaches the real present point in time. It then sends me my new, updated position so that I can correct any errors that have built up on my own client since then. Another benefit of this system is that we also gain automatic cheat prevention and a more robust and fair collision system, if you will, amongst all the different players, since I can say when I think I moved relative to the other guy, but at the end of the day, when there are discrepancies, the server can correct for it all and minimize any differences that we're going to see. A couple of other minor things to note here are that all of the movement data from the physics thread can easily be seen by the scripting thread, and vice versa, thanks to that multi-threaded architecture we've written, so that I can, for instance, see the UI scripting, or use the UI scripting system shown earlier to make, say, a mini-map, as you find in many modern games, and it would be able to get the position data that's being sent across the movement's UDP networking system without having to tie it directly into that networking itself. And all of this could be done pretty transparently in the code, so systems like this aren't hard to implement. Also, I'll go ahead and show the camera a little bit throughout the demo. It's pretty similar to, say, the World of Warcraft camera, just a simple third-person mouse and keyboard control system. Normally you would not be able to see the cursor in the center of the screen. I apologize for that. The code covers that up, but the screen capture software I'm using requires that it be visible. And that should be about it for this client. So now that I've covered that, let's go ahead and show off collision. I'm going to go ahead and log into another client here. The process isn't really different. For right now, I'll just fire up a client, move its developer console down to the corner, and for development, we have left it so that accounts can be logged in multiple times at any given moment. So I'll just log into the admin account again. And here we are. So off on the corner of the platform, we can see our friend standing. We'll go and move to him now. And as we get closer, you should be able to see that his animation is also showing up on my screen, since his current state is broadcast to us, and that's all we really need to determine the animation we should be playing for him. So I'm going to go ahead and position myself here, and what I'm going to do is I'm going to run up and bump into him, and when I do that, you should be able to see a little bit of a jitter and a correction, and then once that's done, the positions of both of us are going to match on both clients. So as I'm bumping him now, you can see that jitter. And the jitter is just a sign, basically, that rewind and replay is working. Since one client is seeing the collision later than it actually occurred, its results aren't quite synchronized. And there's a bit of a snap, and that's the jitter that we see. And I'm actually currently working on smoothing that out over time, since, I mean, as a developer, we like to know that it's working, but as a player, it doesn't really look right. So, you know, it's a pretty standard feature in games that use this system to smooth that out over time. And yeah, so once I've bumped into him a few times, we can see that we still show up basically where we ought to on each other's screens. So that's Project Crusade as it currently stands. Thanks for watching, and I hope you enjoyed seeing the progress so far.